Hello. For the past several weeks, I've been taking a course through Google, their Gen AI intensive course, meant to train people on the capabilities of their Gemini system. As part of that program, they have a Capstone project, which is a 2-week project where they ask you to come up with a use case to demonstrate what you've learned. So I'm going to be demonstrating implementing an AI counselor agent with the capabilities that they've shown. So hope you enjoy it. The first step is to develop a model for predicting the emotions within a conversation. This can help therapists and counselors to help their clients to better assess what their state of mind is and their emotional state. So let's dive right into the Jupyter Notebook. This is assessing the emotion in counseling chats. This is the first of 2 steps, and this will demonstrate embedding, Gen AI evaluation, function calling agents, and long context windows, which were some of the topics covered in the Gen AI intensive course. So the first thing I searched for was input data, conversations from therapy or counseling conversations. There isn't a lot of that online because a lot of that is private, of course, for understandable reasons. I did find a series of synthetically generated conversations, that is, conversations generated by another large language model, which was put on Kaggle by Jerry Yao. So thank you very much, Jerry, for the raw data. I took that and whittled it down to 500 conversations that would be the benchmark and form the basis of the training and validation data for our model. So once we have the 500 conversations in the program, I split them up into 400 training conversations and 100 validation conversations. We do this via the sklearn modules that are a standard part of data processing. The next thing we need to do is actually convert these conversations to embeddings. So all of the neural networks and so on will work with embeddings. They don't work on the raw data themselves. So the first step is to actually convert the conversations into essentially a 768 element vector to be processed within the Keras framework, which we'll see in a moment. So practical consideration is that we needed to reduce the training size appropriate to the compute resources that we had. So even though we started off with 99,000 conversations, I found quickly that the compute resources that I had could only handle about 400 to 500. So that's why we cut it down. Next, we take those embeddings and actually convert them into data structures for use in Keras. So just some Python manipulation to get them into the right structure so that we can pass them to those functions. Next, we need to take the 5 emotions that we've defined: depression, grief, anxiety, loneliness, and financial stress, and actually convert them to numbers, because a neural network works fundamentally on numbers. So these are the categories that we will be training to. Next, we need to define our neural network, the structure of it. So there's going to be 768 inputs feeding to a hidden layer of 768, and that leading to a output layer of 5 elements. In total, there's going to be over 500,000 trainable nodes in this network. The numbers get pretty big. I think that this is adequate for the function that we're trying to model. Next, we need to train the model. Some of the key parameters that we're going to set are the epochs and the patience level. So the epochs 100 is the maximum number of iterations that we're going to go through, and the patience level of 7 will mean effectively that we will train until 7 iterations no longer give us an improvement in the accuracy. As you can see here, epoch number 54 had an accuracy of 87, and the model stopped training after that because it was not improving. So this is done for two reasons. First of all, you want to conserve costs and compute resources, which are very expensive. So if you're not getting any improvements, you just stop. Also, you do not want to overfit your data to the data that you have. So that will limit its predictive value. Next, we save the model because we're going to use it in the future. Here we see the testing against one incremental conversation, and we see the output. So across depression, grief, anxiety, loneliness, and financial stress, we see that anxiety is the emotion that is most highly predicted. So we could talk a lot about the different tests that I ran, but in the interest of time, why don't we move on to step 2, developing an AI counselor agent. In this section, we're going to define the agent and also define the tool for assessing the emotion based on our work in step 1, and then actually see a implementation, which is pretty interesting. So the result of what we do here today is going to be a agent with the following structure, defined within LangGraph. A lot of you will be very familiar with this type of a structure. It has the AI chatbot, it has the human, which is in our case is the client, and it has the tools that or a tool which the agent can use to assess the emotions of the client. Okay, so let's get into the code. First is the documentation at the top, implementing the agent counselor chatbot. So we're going to use the model from the first step, incorporate it into the second step, and define our agent, demonstrating the embedding, Gen AI evaluation, function calling, agent, and long context window capabilities that we learned in the course. First thing we're going to do is to load the emotion prediction model generated in the first step. This is going to be part of the tool set that we actually allow the agent to utilize. So there are two key parts to the tool. The first is the defining what the chatbot actually is, or what the agent is. We tell it it's a counselor, its job is to make people feel better, and so on. The second thing, which I find more interesting, is we actually instructed it on the type of input that its tool, the assess emotion tool, takes. So I was having a lot of trouble trying to get the messages passed to the tool, and it turned out to be a lot easier to just tell the agent, the AI agent, what it needed to do to use this tool, and it worked beautifully. One of the advantages to telling the AI agent how to use the tool is that I did not have to use the function that I developed here. So a lot of hours went into developing this to try to strip out the relevant pieces of the conversation from the state graph within the LangGraph structure. All the work that did not need to be done. So thank you, Gen AI. So here we define the agent counselor chatbot. The only piece that I want to draw your attention to is the part that where we actually define the tool and the input to the tool, the assess emotion tool. So as I stated earlier, we just told the AI agent how to use the tool, and it would configure the data in the right format to pass to this tool. So that was a pretty easy thing to do. So at the end, we have this agent defined, chatbot, human, and tools. The chatbot talks to the human and tries to provide counseling advice, and the tool provides a ongoing assessment of the emotional state of that. Here we see the output of the tool. You can see there are the 5 emotions that we talked about earlier, and the assessment that that our predictive model provides for each one of them. So in the first stages of the conversation, depression is about 39%, followed by financial stress about 35%, and anxiety about 18%. This gets updated dynamically, as you can see, and one statement from the client about having money troubles ups the financial stress emotion to 99%, and you can see that it jumps around a little bit when he states that he's lost a close friend. His grief jumps to 88%, and and his loneliness to 10%. So it'll continue like this through the end, depending on what the client says and where the conversation goes. In general, these emotions are pretty stable unless the client says something that is completely different than where the conversation has been. So if they talk about financial stress and then suddenly talk about losing a friend, then that will change the assessment dramatically. Other than that, it'll stay pretty consistent with the early parts of the conversation. And that concludes our overview of the AI counselor agent. So a couple things to note. We should have real conversations and need real conversation data if this is going to be useful data, since synthetic ones are just generated by a different LLM. We also need to reevaluate the emotion classifications. I found that a lot of them were overlapping and probably did not capture the emotional state in the conversation well enough or independently enough. And also the counselor AI agent is an aid. It's not really a replacement for, I think, a real world counselor. This can help, but I don't think it should really take the place, at least not in the short term, of an actual person providing the counseling. Thank you very much. Have a good day.